On-site carbon capture reshapes CO2 supply chains. Today, turning atmospheric carbon into a usable input has typically been framed as a large-scale, future-facing ambition. A recent collaboration between Air Capture and Almanac Beer Co. offers a more immediate, ground-level example, placing direct air capture DAC systems inside active production environments rather than distant infrastructure projects. The result is Flow, Clean Air Edition, a commercial beer carbonated using CO2 captured on-site from ambient air. The product may be a first, but the broader signal is more practical. Carbon is starting to shift from a background dependency to something manufacturers can generate and manage directly. Rethinking CO2 as a supply chain input. For most beverage producers, carbon dioxide has long been an essential but externally sourced commodity. It typically comes from emissions tied to industrial processes such as ammonia or ethanol production, creating an indirect and often fragile supply chain. That vulnerability was exposed during the 2022 CO2 shortage, when reduced industrial output tightened supply and increased costs across the food and beverage sector. At Almanac's Alameda facility, Air Capture's modular DAC unit produces CO2 on-site at 99.999% purity, surpassing standard beverage-grade requirements. Instead of relying on upstream industrial activity, the brewery can generate its own supply as needed. This introduces greater control over both quality and availability, while reducing exposure to market fluctuations. The shift is subtle but important. CO2 moves from being a purchased input shaped by external forces to a localized resource produced within the operation itself. For manufacturers, that change could simplify logistics while improving resilience against supply disruptions. Modular DAC moves into production environments. Historically, DAC has been associated with large, capital-intensive projects tied to government funding or major industrial players. High costs and long development timelines have limited broader adoption. Air Capture's approach leans in the opposite direction. Its system is modular, compact, and designed to integrate with existing equipment. At Almanac, installation was completed within weeks, with no need for new construction or production downtime. This lower barrier to entry may be what brings DAC into wider commercial use. Instead of requiring large upfront investments, companies can adopt the technology incrementally, aligning with a broader shift toward flexible, distributed infrastructure. The business case is also evolving. While sustainability remains a driver, on-site carbon generation is increasingly framed in operational terms: cost stability, supply security, and process control, rather than purely environmental impact, toward a more circular carbon model. The implications extend beyond brewing. CO2 is widely used across industries, including food processing, cold storage, agriculture, and construction materials. In many cases, supply is still tied to emissions from other sectors, creating a dependency that can conflict with decarbonization efforts. Capturing carbon directly from the air offers a way to decouple supply from those legacy systems. Instead of relying on emissions elsewhere, companies can source CO2 independently, opening the door to more circular models where carbon is captured, used, and reused within shorter loops. The collaboration also reflects a growing overlap between commercial activity and climate policy. A portion of proceeds from the beer will support carbon removal initiatives, signaling how private sector experiments are beginning to connect with broader regulatory and market developments. It is still early for modular DAC, but the direction is becoming clearer. As deployment becomes faster and more cost competitive, carbon may increasingly be treated less as a byproduct to manage and more as a resource that can be produced on demand.